what do? Well, we need to limit access to the baristas and let customers interact only with our cashiers. And wouldn't you know it, we can use AWS networking to accomplish that. Specifically, a networking concept called Amazon Virtual Private Cloud, or VPC. VPCs help you provision a logically isolated section of the AWS cloud. In this virtual network, you can launch whatever resources you decide on. More importantly, these resources can be public or private. Public-facing resources have access to the internet, whereas private resources do not have internet access. This is perfect for our coffee shop. We can make our cashiers publicly accessible so they can interact with our customers to take their order and process payments. We can then prevent our customers from interacting directly with the baristas by making them private resources. This means, hey, I can focus on making drinks. Refreshing. Okay, time to dive into more networking concepts. Good luck.
All right. So what we can take from this video is that we will have a VPC. I always put an analogy for VPC as this is your store. Yeah. So in your store, you would like to divide your store become the front end and the back end. So at the front end, there will be cashier, just like the coffee shop, that can interact with the customer, in this case, users from anywhere in the world. We're saying it like from the internet. But there is also a spot that we call it as private area. So this private area could be a cook, could be a barista in this coffee shop. And the user from anywhere in the world, in this case it's internet, cannot interact with the barista. So you can also design your VPC with the public and private. Public, you let everyone to interact with, and private, you're going to hide or to protect these resources to be accessible from outside of the world, in this case, in the internet. Okay, so VPC lets you provision a logically isolated section of the AWS cloud. So you can imagine the AWS cloud is so huge, and you only take a part of it, and that will be your coffee shop, your company. All right. And then you will launch your resources within the virtual network later on that we define, which is the public and the private subnet. So here we come to the subnet. So the subnet is used to organize our resources. What is resources? There are three types of main resources: compute, storage, and network. We can make these resources publicly or privately accessible. Private means we use it to contain resources like database or transactional information, basically our internal data. Basically, it's a data that we will not let anyone to access. And a public subnet is usually offered to the customer facing. So anybody can access it. Okay. So you can see the picture here. At first, we have this big cloud, which is the AWS cloud, and then there is a part of it, a section, which is the purple rectangle here. This is the VPC, which is just a part of AWS Cloud. And then within the VPC, we create two virtual networks. We call it subnets. There is subnet 1 and subnet 2. You can say that the picture with the database is the private subnet, while the subnet 2 is the public subnet, or vice versa. It depends on how we are going to design it. Well, the common question is it's not the common questions. The twisting question is, what if I put database or any other transactional information to the public subnet? Can I do that? Yeah, why not? Remember, the AWS shared responsibility model. So the database or any data that you have, it depends on you how you are going to treat it. You want to put it as a private or a public, it's up to you. Okay, but common sense is we put anything secret, anything private to be restricted. And in this case, you would like to use the private subnet. All right. So let's see this diagram to try to understand what the connections. Yeah. First, we have this AWS Cloud as the outermost, and then there is a user that can access our cloud through the internet. Before the user can access our resources within the AWS Cloud, we have to choose what region are we going to stay or to put our cloud in. And then after that, we will create the VPC. Okay. And then this VPC will have AZA, AZB. Okay. And then within each AZ, you would like to create your private network. Virtual network. It could be public, it could be private. And then after you create your virtual network, which is the subnet, and then you're going to create some resources. Let's say in the public subnet 1, you create Amazon EC2 instances. And at the other private subnet 2, at AZB, you're going to create a database, and so on. Okay. Let's see how it works. Okay, so the AWS Cloud is the outermost box in the diagram. And then region, which is the next box, is a separate geographic areas. We choose our region, and then we create our VPC. Okay. And I will see next AZ here are shown as separate boxes across region. So you can see AZ are across region, means it's not across region, it's within region. Yeah. So within region, there is AZA and AZB. You can see that obviously. And sorry. Okay, and then AZs consist of one or more discrete data centers. We know that AZ equal to data center, which each data center will have redundant power, network, and connectivity. These three, yeah? Power, networking, the switch, the hub, the router, and connectivity. Connectivity means through the networking from one server connect to the other server. And it is housed in separate facilities. Means like, data center, you put in all the servers, networking, cables, power, and everything. And then after that, you have another data center that will become another AZ. So it's obviously supposed to be separated, yeah? Because the target or the goal of AZ, multiple AZ, is for fault tolerance and high availability. Means like one AZ down, then you still can use the other AZ. All right. So it's supposed to be separate. Yeah, there is no use if you're not separating it. Like if there is a chaos in Jakarta and AZ A, B, C are all in Jakarta, then you will not have any redundancy, fault tolerance, whatever it says. When it's riot, it's chaos, fire everywhere, right? All right.
Juara.
So now we see subnets. Here's the picture. We can create private subnet 1 at ACA and private subnet 2 at ACB. Well, regarding the question yesterday, is it replicating? So you can see now that AZA and AZB can have different content. Yeah. So if AZA down, how will it automatically pick up at AZB? Unless you are explicitly saying that the database within private subnet 1 is actively or maybe not really active, like you trigger it manually to do the replications all the way to the database within the private subnet too, right? So you have to do it explicitly. Yeah, means like you have to configure it before it will happen automatically. So there is no such magic here, because you know what, according to the shared responsibility model, anything that you make within the AWS cloud, of course, AWS will not know what do you want to do with those resources. So we have to tell AWS cloud what to do with our resources. Like per se, the database needs to be replicated to AZB, then you have to configure it so that the database will do the replications automatically, kind of that thing. All right. So the main goal of the private subnet is to design an isolated resources which cannot be directly exposed to the public internet. So we just want the resources there for our internal process. Let's say we have an applications like Tokopedia. Okay. The data regarding what item are sold in a Tokopedia, we don't have to tell it to the customer. But for the customer, they only need to access our websites and we display the data through the websites. That's all. But there is absolutely no valid reasons for the customer to go directly to our database and can tweak into display whatever it is, right? Because that's our quote unquote kitchen. You don't have to come to the kitchen. If you come to a restaurant, you don't have to come to the kitchen. You just sit down on the table and order your food, and then we will cook it, right? So private subnets is our kitchen, kind of that things. Yeah. Right. Then public subnets. Public subnets is looser, means like you can let anyone to access your resources. So it is designed to provide direct internet access to resources, places, place inside them. But even though so, you still need to explicitly create an internet gateway here, yeah, so that any user from the internet can connect or can access through your VPC all the way to your public subnet and access your resources here through the internet gateway. Yeah. If there is no internet gateway, we say, I put all my resources to the public subnet, and now you can access it. No, you cannot access it until an internet gateway. This is the door for people out of the internet come in, and actually all the resources can, per se, you want to install Ubuntu Linux within your EC2, then you have to download all the resources, right? So this Amazon EC2 can also go through the internet gateway all the way to the Ubuntu repositories and then download all the resources it needs to install Ubuntu within EC2. So it can go in and out through the internet gateway. Yeah. All right. Okay. So now just a small questionnaire to test our skills, whether we still sleepy or not. It's 8 o'clock in the morning. What are the uses of subnet in an Amazon VPC? I would like you to vote. I mean, like, you can put your answer in a message box. All right, will you do that? We'll see ya. Number one, what are the uses of a subnet in an Amazon VPC? Select three. Okay, if you want to join or want to register yourself and take the exam, you have to really pay attention on the definitions here, like the select three or choose the best one, kind of thing. Yeah, because a lot of time we miss this one and then we cannot answer correctly. We just answer one or two of them. Okay, so let me see. In the in-call messages, you can put your answer. Yeah, number. Okay, Toyib 1, 2, and 5. Another one. Okay, Paris 1, 2, and 5. Douglas 1, 2, 5. Adam 1, 2, 5. Acne. Okay. Kevin 1, 5, 6. All right. So 6 is the differences. Any other? 1, 2, 5. All right. Are all here? Give me your answer. 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. 12 students. Where's the others? Another 3. Absent. Okay, anyway, we're going to see 1 to 5. What are the uses of subnet in an Amazon VPC? Can be used to share public resources. 1, okay. And then can be used to organize your resources within the public and private subnet. And then can be used to provide high availability because it consists of one or more discrete data center. It looks like yes, but if you think it a little bit more, discrete data center with is the AZ, right? While the picture itself, if you still can see it here, the VPC is beyond AZ. Yeah, we'll see. Can provide a centralized interface for accessing and managing various AWS resources and services. Centralized interface, maybe what it means is the internet gateway. Yeah, but managing various resources and services, we'll see. Can be used to isolate resources and keep them private. Well, in case of the private, yes, right? We'll see if your answer is 1, 2, and 5, this one. and then can be used as an on-demand and scalable computing capacity. Well, if it's on-demand and scalable computing, this is auto-scaling. It's out of the topic of VPC itself. Yeah. So 6 could be not. Let's see, Kevin. Let's submit it. Is it 1 to 5 or other? Okay, it's correct. So it's 1 to 5. Yeah. Subnets. This is, you can read one of the interesting thing about exam like this, it will give you an answer and you can read it again instead of like reading all through chapter 1 to chapter 10 like that. Yeah, so you can learn from here. Subnets are used to organize resources. Okay, we can organize it within public and private, and then we can share resources publicly, isolate them to keep them private. That's all. So that's subnet. Yeah. So again, subnet in VPC, subnet is to organize private, public. That's all. Yeah. Okay. Okay, let's go to lesson 2. Oh, maybe any questions about this? Any questions? Why 3, 4, and 6 is not? Well, for 6, I can tell you that this is about the EC2. Yeah. It can be used for on-demand resources. You can configure EC2 as an on-demand resources, and it can scale the capacity through the auto scale. Yeah. So it's EC2 and auto scale. So it's out of the topic of subnet. Yeah. The question here is subnet. Can be used to provide higher availability because consists of that. That is AZ, yeah, not subnet. Can provide a centralized interface, that is internet gateway. Okay. Or virtual private gateway. We already see that, right? Yesterday, for the user that want to access our resources through a secure channel, they can use VPN. So for VPN users, we have to provide VPG, virtual private gateway, right? And remember, for a faster channel, but still secure, we have direct connect. Okay. Okay. If there's no questions, I'm going to continue with how are we going to organize our cloud resources using private subnet and public subnet. Let's watch this video.
To reiterate, a VPC or virtual private cloud is essentially your own private network in AWS. When you use a VPC, you can define your private IP range for your AWS resources and place things like EC2 instances and elastic load balancers inside of your VPC. Now, you don't just go throwing your resources into one big VPC network space and then move on. Instead, you place them into different specific subnets. Subnets are chunks of IP addresses in your VPC that you can use to group resources together. Subnets, along with networking rules that we will cover later, control whether resources are either publicly or privately available. This idea of public compared to private access to resources is super important. For some VPCs, you might have internet-facing resources that the public should be able to reach, like a public website or a load balancer, for example. However, in other scenarios, you might have resources that you only want to be reachable if someone is logged into your private network. This might be internal services like an HR application or a backend database. First, let's talk about public-facing resources. To allow traffic from the public internet to flow into and out of your VPC, you must attach what is called an internet gateway to your VPC. An internet gateway is like a doorway that is open to the public. Think of the coffee shop. Without a front door, the customers couldn't get in and order their coffee. So you install an entrance, and the people can enter and exit when coming and going from the shop. The front door in this example is like an internet gateway. Without it, no one can reach the resources placed inside of your VPC. Next, let's talk about a VPC with all internal private resources when you don't want an internet gateway attached to your VPC. Instead, you want a private gateway that only allows people in if they are coming from an approved network, not the public internet. This private doorway is called a virtual private gateway, and it allows you to create a VPN connection between a private network, like your on-premises data center or internal corporate network, to your VPC. To relate this back to the coffee shop, this would be like if the coffee shop was located inside of a private corporate office building. If I want to go get coffee, I have to badge in to verify my identity. Then I can access the internal coffee shop that only people with access to the building can use. So, if you want to establish an encrypted VPN connection to your private internal AWS resources, you need to attach a virtual private gateway to your VPC. Now, something to note about the coffee shop in the private corporate office building is that this building is shared by multiple companies, and there are a lot of people who work here. Even though I have special access to the coffee shop, I still might have to wait for the elevator, navigate crowded hallways, or stand in line. This is similar to how a VPN works. While it provides a secure connection, it still routes your traffic through a shared network, which can sometimes lead to slowdowns, especially when many people are using it at the same time. It's not that the VPN itself is slow or a bad option, but rather you may need higher bandwidth or a dedicated line in certain scenarios. Now, if I had a direct, super secret magic doorway that led from the studio straight into the coffee shop, I'd bypass any congestion and have a reliable, high throughput coffee connection at any time. That sounds pretty nice. This is a similar idea behind wanting a dedicated private connection to AWS. With AWS, you can achieve that using a service called AWS Direct Connect. Direct Connect lets you establish a completely private, dedicated fiber connection from your data center to AWS. It ensures both security and consistent high performance. You work with a Direct Connect partner in your area to establish this connection because, like my magic doorway, Direct Connect provides a physical line that connects your network to your Amazon VPC. This can help you meet regulatory and compliance needs, as well as sidestep any potential bandwidth issues. Thanks for listening. I'm going to hang out here and keep ordering magic drinks from my magic door. See ya.
All right. Okay, now we are going to see how we are going to organize our resources in the AWS cloud. So let me read out for you so you can have like a visualization of how actually it works. So you are asked to imagine if millions of customers who use AWS services will come and will come to your cloud and create some resources. In this case, it's Amazon EC2 instances. And then the thing is that if you don't have any boundaries for all these resources, you can imagine how network traffic will be overburdened because anybody can access your network. And what is worse, it's unrestricted. Okay. So we need some mechanism, some system, some tools to be able to organize these resources. One of the things that we can apply is AWS VPC. And then when we have isolated all these resources within our VPC, the thing is, how can millions of those customers be accessible to the resources because it's isolated, right? You can see here that the AWS cloud by default is secured. You can see the padlock here. Yeah? It means AWS cloud is secured by default. So that means if you want to get access into the cloud, then we need to provide one. In this case, we will provide a gateway, yeah, a door to connect the users to the resources they require. Right? And then within the VPC, we can organize our resources into subsections, or it's more common to say it as subnets. The subnet is a sections in the VPC that can contain resources. So why would we have a subnet? Because just within a subnet, we can place a resource like EC2. If you only have VPC without any subnet, and then we want to create an EC2, that's impossible, right? So that's the mechanism. After you create VPC, you have to create at least one subnet, which is the public or private, it's up to you. But at least you will have one subnet so that you can place your resources. And then after you create your resources, in this case, it's like the EC2 instance, then you would have to allow users to access your resources. In this case, you're going to create an internet gateway. This is the basic one. So through the internet gateway, a client will send a request through the internet into the VPC. Per se, you're going to let the client to SSH to remotely log into your EC2. And so you have to provide this internet gateway so that SSH can pass through. Well, how to allow SSH? We will see that in the security group. But anyway, for the users that using VPN, or in the language that lady just said, if you want to have or to allow access only from unauthorized resources, unauthorized party, that means we require that any connections have to have security. So one of the way is using VPN. So we'll see here. What if you have a VPC that includes only private resources? In this case, we only have one subnet, and we only create the private subnet. We are not creating the public, only private. First, we think the internet as the road between our home and coffee shop. It's open, accessible to anyone. This is the internet gateway. But then we want a way to protect the traffic that people send from internet to the public, internet service providers or others who might want to try to track or intercept it. We want to protect this hacker. So then we required a VPN connections to come in, only VPN connections to come in. Then we will change the internet gateway and we will apply virtual private gateway, which is VPG. VPG only allowed a VPN connection to pass through. Yeah. It creates a connection that is more like a secure tunnel through the internet. So again, the keyword here, it is a secure tunnel, but it is still going through the internet, the same highway with the other internet users. But then it uses encryption. It hides and protects everything that a user will send and receive from outside the eyes. So a VPG will enable the connections from a VPN user. VPG is a component in the AWS cloud that will make possible for this connection. With a VPN connection, the data that is sent and received through the internet will supposedly, well, I can say, will be absolutely private and safe, hidden from anybody that is using the same route. Why it's hidden from other using the same route, which is the internet route? Because again, it's like a secure tunnel. So you can imagine we have a road, and then under the road, people build a tunnel for the water to flow through. So with the same road, the same highway, it is built a secure tunnel, that is VPN. And of course, people riding motorcycle, driving cars on the road will be obfuscated, will be put away. They cannot see if there is a tunnel under there. They just hear, yeah, there is a tunnel under here, but they cannot see it. Yeah. So that's a secure tunnel. People know there is a VPN tunnel, but they cannot see it. So it's hidden. Yeah? With a VPG, we can establish a VPN connections between our computer with VPN connections to the private network, such as on-premise data center or internal corporate network. So from VPC, you can access, from your data center, you can access the VPC. Like from your office, or even if you're working from home, yeah? Well, sometimes I work from home, but I need a secured access to the server in master system. So we use a VPN. I have to install a VPN client and the certificate that is only approved by master system. So when I turn on my VPN and then trying to connect to the server, they will challenge me with the credential and certificate. Once it's approved, I can have all the access as if I am within my office, within master system. Yeah. So we can work from home and have VPN connections to connect to the private resources, such as the private subnet within the Amazon VPC. Okay. A VPG allows traffic into the VPC only if it is coming from an approved network. Okay. Like I told you, even though I'm at home, what is called approved network, that is, if my laptop have the certificate authorized, authenticated by the VPN server back here in master system. Yeah, so we cannot use any certificate, but the certificate approved only by master system. All right. So it is said that several of the preceding networking components have similar abbreviations and are often confused. These components are core building blocks that you will use in many AWS cloud solutions. To learn differences between these acronyms, choose each of the following flashcards. So to summarize, we have a lot of abbreviations, a lot of name that is actually a core building blocks, and you cannot pass this through. Yeah. You cannot skip it because this is core building blocks. You have to understand it before you move forward. So AWS Skill Builder is generous enough to give you a flashcard like this. So you can only pinpoint to the topic that you want. Like to say this is VPC, yeah, VPC, VPG, and VPN, right? It will absolutely confusing for the first comer like that. We'll see. VPC used to establish boundaries around your AWS resources. Okay. So again, remember the analogy that VPC is used to as a house for all your resources. Yeah. So remember when we say we're going to move from old house to the new house. The new house is the public cloud. The old house is the on-premise. And then when we say we want a public cloud, then we will register to AWS Cloud. AWS Cloud will give us user ID and password. As you have registered, you will get the root email as your first user ID, and then you can log in through the help of AWS console into our AWS Cloud. So those AWS Cloud is still like wide and huge, and there is no boundaries. It's like a flat land with no fences. So your neighbor can anytime cross path your house. In that case, you want to put some boundaries around your houses. That is the VPC. So when we create fences for our house, that's the same like we are saying we are creating a VPC. Okay. And then of course, after we create the fences, and then we build a house, the house itself also are resources. Then we move all our furnitures, everything from old house to the new house. All those are resources also. So the resources we can say also reside within a VPC. But then remember that we cannot put any resources scattered around VPC. You have to have a plan how to manage it. Like I said, at least you will have one subnet. It could be private, it could be public, it's up to you. If it's public, then you put everything within your public subnet. Okay? Until you provide an internet gateway, people can come in through the internet gateway. The users from the internet can pass through the internet gateway and use your resources. So it has to be explicitly configured to have an internet gateway and so on. And then the next thing is VPG. VPG is a secure tunnel, yeah, for VPN users to pass through and access our resources. Shortly say, it allows protected internet traffic to enter our VPC. So if you only have one private subnet to put all your resources in, you do not want anybody else to access it. But somehow, as the owner of the house, you will of course sometimes going out to buy some groceries, and when you go back in, you cannot pass through if you don't have the requirement to pass through the VPG. In this case, you need to be an authorized users. In this case, you have to have a VPN, you have to have the user ID and password and the certificate. And then you can go through the virtual private gateway. It's a little bit restricted and it's a little bit like, tedious, but security trade-off is always the simplicity. Yeah, simplicity means unsecure. Usually, if you want a secure one, like maybe you experience when we have to access this skill builder itself, the process of the login pass through like a couple of a web page, I think, before we can come and access our skill builder. But anyway, the next one is VPN. VPN encrypts our internet traffic. It helps to protect it from anyone who might try to intercept or monitor it. Anyone trying to intercept and monitor it, it is called the hacker. So basically, VPN encrypts our internet traffic to prevent us away from hackers. All right, so it's glad to have this flashcard, so you always can flip and flip back like that if you forget. Let's see these questions. A company is setting up their Amazon VPC. They need to connect their corporate data center through the internet with a secure connections. Yeah, this is the keyword. They also want to make sure the resources are isolated from the public. This is also another keyword. Yeah, resources isolated from public, so it's private, and the connections um, to okay to connect corporate data center, their corporate data center through the internet with a secure connections. All right. So which solutions would best meet their needs? First, internet gateway with a public subnet holding the resources. Well, the keyword itself is already public, which is supposed to be isolated. Yeah, so it's not this one. A VPG with a VPN connection and a private subnet in the Amazon VPC. Looks like this one, right? Because VPN is VPG, and for isolating the resources from public, we need private subnet. We'll keep that. An internet gateway with an Amazon VPC and no subnets. Of course, no subnets, no resources can be put in. Internet gateway with an Amazon VPC and a public subnet. Okay, it gives us some keyword, yeah, to give us a clue that we know that it's not public subnet. So anything with public subnet is not valid. No subnets, no resources. So even though we might forget about VPG, you can guess it's supposed to be private subnet. So out of these four, the only one with private subnet is only B. Let's see what's your answer. You're not answering? Okay, anyway, we'll see. Let's submit it. All right, so it's B. Yeah. Let's continue. Or any questions before we move forward? Okay, it's 8:55. I think we need to have a break, 5-minute coffee break. Get your coffee and get back here. We'll start again by 9 o'clock, 900. See you again soon. All right, bye-bye. Get your coffee, don't forget, get a toilet break also. Yeah.
Okay, sir.
Okay, sir.
All right. I hope you have your coffee in hand, right? Let's continue to lesson 3, more ways to connect to the AWS cloud. So we already knows IG, Internet Gateway, VPG for VPN users, and also Direct Connect. Yeah. Well, do not expect that we are going to, or AWS is going to provide any like deeper deeper explanations about Direct Connect because it is not common. Yeah, even only certain corporate will apply that because it's expensive. Yeah, one of our client, Telkomsel, they have Direct Connect. Yeah. So far, we only have Telkomsel that have Direct Connect out of like maybe tens of customers that we have using AWS public cloud. Only Telkomsel have that. So it's not going to be like general discussions within any AWS material, yeah, certifications. Even solution architect is not diving deeper into the Direct Connect. Yeah, we don't really like have to pay attention on that because when there is a customer like Telkomsel needs a Direct Connect, mostly we only do a project management things. So we contacted Lintas Arta. We arranged the meeting with Telkomsel, Master System, and Lintas Arta. And then once Lintas Arta know our intentions to have Telkomsel get the Direct Connect, all Telkomsel needs to do is to sign a form. Once form is submitted and approved, then Lintas Arta just provide the fiber channel to connect to Telkomsel and AWS Cloud. Just that. Yeah. And then monthly, they have to pay huge amount of fee for the direct connect. That's it. Yeah. So you also have to see that you have also have to be capable of generalizing. Connectivity is connectivity. Once it's connected, business as usual. Yeah. Whether it's VPN or SSL, once it's in place, that's it. Business as usual. AWS selling services. So that will help you to simplify you or prevent you from focusing to the nitty-gritty that you don't have to really dive deeper into that. Okay, let's see. First, we are going to see AWS Client VPN, how and when to use it, and then site-to-site VPN. Yeah. So previously, you only know VPG user have VPN, connect to the connect to our AWS cloud, access to our VPC to the private subnet. But then we will see site-to-site VPN. Also have AWS private link. And the last is direct connect. So basically, the idea is to see hybrid cloud connections with the AWS cloud. Means, still remember 3 types of deployment. First, on cloud. Second, on-prem. Third, hybrid. So hybrid is to connect on-prem to cloud. Yeah. In this case, maybe from a client office, client data center to the AWS cloud. Yeah. There are 4 other ways to connect on-prem to on-cloud. First, using AWS Client VPN. So Client VPN is a networking service that we can use to connect remote workers and on-prem network to the cloud. Remote worker means, like I told you, I used to work at home, have a VPN client installed, have the valid certificate to access master system data center from my home. So I am the remote worker. But also, we can say from our on-prem networks, we can connect to the cloud. So from master system data center, we can connect to the AWS cloud. But we are not, yeah. Our client, we connect their on-prem network to the cloud. Well, Telkomsel is one good example because the implementations over there is quite complete. We are not only playing with all cloud, but also hybrid. So Telkomsel also buy what's called AWS Outpost. Outpost is a physical server that is provided by AWS. Even though it's a server on our premise, you still cannot tweak like as a common server. Yeah, it's hardened. It's what's it called? Hardened and protected. So it's just like a black box to Telkomsel. It was put there, connected to the network, and voila, this outpost turned to be one of the quote unquote like EC2 resources for the AWS. Okay, so that's on-prem, on-cloud solutions from AWS also. Client VPN is fully managed, elastic VPN service that automatically scale up or down based on user demand. Because it is a cloud VPN solution, you don't need to install and manage hardware or try to estimate how many remote users to support at one time. So AWS Client VPN, it's a service, a networking service. Yeah. The benefits of AWS Client VPN, it provides advanced authentication, remote access. It is elastic and fully managed. When there is a word elastic in AWS, that means it can grow or scales based on user demand. So in this case, it scales up or down based on user demand. This is called elastic. Fully managed means it's fully managed by the AWS. So the service itself is not the user responsibility. It's AWS responsibility. So it's fully managed. AWS provides the services. User only use the services. Like as if you are using EC2. You cannot create your own EC2, but you can use the EC2. So AWS Client VPN is like that. So it's fully managed. The use case is AWS Client VPN can be used to quickly scale remote worker access, because we cannot know, like even master system, we cannot know how many worker will turn to be remote at a certain day. That means the IT department has to provide the certificate for any remote worker that work from home on that particular day. That will be very troublesome if every time IT department have to do the census, who is going to use or who is going to work from home today, like that. Yeah. So the solution is to have elastic kind of services that can scale based on the usage. Yeah. So when you want some flexibility for the remote worker access to connect through VPN, then you can use AWS Client VPN. So you can see here remote workers from anywhere wants to connect to the AWS cloud. In this case, it's a corporate public cloud. Then a client VPN, a managed VPN service, provides secure access to AWS resources and on-premise networks from anywhere. It will use open VPN-based client. Yeah, you can search through these open VPN-based. Yeah, because if it says open VPN, it's supposed to be open source one. Yeah, and then this open VPN base works with global regions by using the AWS Global Network. So it's compatible. Another way to say it's compatible with the regions of the AWS. Okay. And then the second way is to connect site to site from on-prem to VPC. Let's see. The case is some companies might want to establish a secure, this is the keyword, encrypted connections, yeah, still secure, between their on-prem network like data center or branch offices and their resources in their Amazon VPC. So again, it's between the on-prem data center to the VPC. What is not included? A remote worker. So it's not for remote worker. Remote worker, an individual have to use client VPN. But if it's a data center connect to Amazon VPC, it has to be site to site. So site-to-site VPN will create a secure connection between your data center or branch offices and your AWS cloud resources. What is the benefits? Site-to-site VPN provides high availability, secure, and private sessions. And of course, it will accelerate applications. Why? It can accelerate applications. So you can imagine your applications originally or originated in your data center or branch offices. But then you want a backup or you want a second system that will stay in AWS, in the public cloud. The thing is, if you don't have a side-to-side connections between your data center and the AWS cloud, that means you have to log in and out. And if your applications have to connect the database that resides in your cloud and vice versa, then you have to provide like credentials. All those nitty-gritty, tedious kind of prerequisites, you have to provide everything. Yeah. And of course, that will slow down your applications because you can imagine if you ever create an applications, like for login, you will create a login menu. Then before you can access your applications, user have to type in their user and password, right? And then after some times, after your applications do an authentications all the way to your security system, once it's approved, valid, then you are allowed to access the resources according to the role. That's the same if you have a second system in AWS Cloud. You have to provide the door so that your applications in your data center can connect to the AWS Cloud and then access the resources. So every quote unquote, every stop will introduce some latency, some delay. And that will slow down your original applications, which, originally they don't have cloud, so they only work within your local network, right? By establishing a connection, a dedicated connections like this, site to site, with a VPN, securing it with VPN, the applications will treat any resources in your AWS cloud as if it is within the reach of local network. You can imagine there is no boundary anymore. Yeah. So then your applications can just connect to another database within your AWS cloud. So of course that will accelerate the application's performance, right? Provides high availability, of course. If your system on-prem down, then your cloud will take over, and vice versa. Secure and private sessions because it is using the VPN to encrypt and decrypt the data flow through internet all the way to your cloud and back. Yeah. The use case is you can use it for application migration and secure communications between remote locations. That is one thing. Or if you want to have a database in your AWS cloud, but the application stays in your on-prem, or vice versa, the applications run in cloud, right on cloud, the database runs on-prem because of the regulations. Like Telkomsel, they're one of the public telecommunications, which is the facility that our state own, like partly as it's a big women, yeah. Then the data cannot flow out. It cannot be resided in another country. So in that case, Telkomsel will still keep their data in their on-prem data center. But then they want to have the auto-scaling things. They want to have some elasticity. They want to have an edge A that is not come from their own system, but another system. And they have to be efficiently manage their hardware resources. They don't have to efficiently manage the hardware resources. So the best choice is to put it on cloud. So in that case, data stays on-prem, application stays on cloud. And then once it's established the dedicated connections side to side from Telkomsel to AWS using the VPN, then the applications will access the database as if it's in their local network. That's the case. But a lot of people use it for applications migration and secure communications because it's VPN. That's also fine. All right. Any questions before I move to the next one? There is a lot of things that you have to collect, so I allowed some questions. Any questions? Yes. Yes, Kevin.
Okay, sir. Uh, so I want to align my thought about the side-to-side VPN.
Mhm.
It is used for we access from the main data and the main headquarters. I mean, the data center into the branch, and then the next branch. Is it
It can be used like that. So you want
okay?
to connect branch office, data center, like as in the picture, also like manufacturing site. You want to have a secure connections among you,
I
or
see. I
since
see. I
you
see.
have the cloud, you also want to put some resources there. You want your branch office to be able to access the resources back in the VPC also can.
Okay. Okay. So, my question is like, why we have to use set to site VPN instead of a direct connect to the branch, sir?
Instead of
Instead of direct connect, we can actually just
dry
direct
direct
connect,
connect or dry connect.
to the
Direct connect.
branch.
Okay.
We can do that. Like, is it?
Yes, of course. You can.
So instead of set to set, or
No, it's direct connect because
or
site to site, you see it like only VPN mechanism. If you ever um, buy a VPN connection, like from VeriSign, you get a certificate, you install it in your laptop, then you can access Netflix, something like that. Okay.
oh, I see, I see, I see.
So there is no such physical work like pulling the cable, pulling the fiber cable all the way from branch office to AWS, but it's only the work of certifications, installations. So using VPN side to side, the branch office will be installed with VPN client, data center also, and manufacturing site also installed with VPN client. And then in the AWS cloud or in the VPC, you apply the services side to side VPN. Okay, there is a service there. So you configure it, and then of course it will generate some certificate that is used by branch office, data center, and manufacturing site. So when the certificate was injected into the data center, that means you don't have to install each and every laptop with that particular certificate generated by the site-to-site VPN services. So you only need to inject that certificate at one point in your data center. So your branch office later on can access VPC all the way from, they have to go through the data center first, and then the data center will go to AWS.
Oh, I
Or in
see.
our picture, in this case, maybe because of the considerations of the distance, remember, distance means cost. So they do not want to make the branch office to go to data center first and go to the VPC. but they allowed branch office to directly connect using site-to-site VPN all the way to VPC. That's also possible, right? Because of the considerations of the distance, considerations of the performance, because latency from branch office to data center, yeah, and maybe also some internal policy of the company. But anyway, these kind of configurations is of course doable. And another variations of this, instead of branch office side connect directly to site-to-site VPN in the AWS cloud, it can connect to data center first, and from data center go to VPC. But that's all site-to-site VPN. So you can see here there is no physical cable things, configuration port in the router and kind of that things that happens in the site-to-site VPN. But later on, when we see about direct connect, there is some physical work regarding the connectivity. Okay?
Okay, sir.
All
I
right.
got it.
All right. Zufar.
Yes, sir. So I want to ask for the VPN. It was previously said that it has the elasticity feature so that it can scale up and scale down regarding to the user's traffic. I want to ask regarding to the cost. Is it based on the uh, when the user is up and then the cost is linear, is up, and when the user down is down, or is based on the our previous payment? Because I see that when using the service we can choose some kind of payment like reserve payment, or and or on the spot payment or on demand payment. So
Yeah.
regarding to the cost, how does it work?
Yeah, very good questions. Yeah. So about the cost itself, one thing that a lot of users like to use public cloud, in this case AWS, is the pay as you go. So elasticity applied in the AWS client VPN also applied the same mechanism of paying. So if one worker connected using the AWS client VPN, during the connectivity, they will be charged. But if they are not connecting, then there is no charge, as if there is no client VPN applied there. Right. Okay.
Okay, sir. So it's based on the traffic, yeah.
Yeah.
Okay. Thank you.
But actually, if you want to go into more detail about this one thing that when remote worker connect using AWS client VPN, then it will be charged, right? But the thing is that when no worker connected to the AWS client VPN, but the AWS client VPN services still have to be enabled first, right? When you are enabling a service in AWS, there is also a cost. Unless you stop the services. So you apply first, it's enabled, it's running active, then remote worker can connect using the AWS client VPN, okay? In terms of the perceived connectivity costs, they will count flexibly. One remote worker connected, then it will be charged for one worker. Second worker connected will be charged for two people, and so on. No worker connected, there is no connectivity cost, but there is a service cost because the AWS client VPN is still there and running, standby for any connectivity that is possible. But if you think that if your company policy is like this, the policy is if there is a need to have a VPN connection, then they have to email the IT department first. Okay, the operational working hours is from 9 to 5, and then it will be provided 24-hour, means day plus one. After you email, then you will be able to use the VPN the next day. Okay, so by that mechanism, by that policy, IT department can say if there is no queue of requests from the remote worker potential, they don't have to turn on the AWS Client VPN service because it doesn't have to be standby 24/7 for any remote worker. Okay, so simply saying, if it's not used, you just turn off the service. Then there is no service cost. Of course, there is no connectivity cost. Okay. Same like EC2. If you only you are not using it, you say, but you already installed it. Okay. You already launched on EC2. But if you're not shutting it down, you will be still calculated the cost for, the standby EC2. So that's why when during the lab, during this bootcamp, I forget to tell you also, when you create EC2, don't let it just like that. Shut it down because you can restart it anytime. Right? After you use, you try, okay, you can record the video for the submissions of the assignments. But after that, shut it down. When you want to do the demo, turn it on again. Okay, that will save you some money. All right, so far.
Okay. Can I ask one more question? Just
sure.
come up to my mind. So for this AWS client VPN, is the service only used to connect from the on-premise network to the cloud, or is there any other service that we can use if we want to connect the remote worker to the perhaps the on-premise network? So so it's still basically the same office, but we only use the AWS service as VPN to connect from our network worker or from our our network worker to the perhaps the branch office.
Yeah. When you want to provide an access for your remote worker, in this case, employee who work from home, to your on-premise, it's always have to be secure. That is the mental mode. Yeah, the mental mode is anybody from out of the premise and want to access the resources have to be secure. Okay, so if you want to have a secure connections, you can only have VPN. So that means you create a tunnel using the internet network traffic. You create a tunnel all the way to your on-premise data center or branch office. Okay. So if you say, I want to create a tunnel, in this case, I want to apply VPN. So you have to apply some certificate. There are two ways of doing it. Yeah. I put that side first. So when you create a VPN, you need to provide your remote worker with a certificate so that they can access it. They, of course, user ID, password, and a certificate. The certificate client have to be injected in their laptop, and then once they're connected, that means the connection itself is in the tunnel. It's secured already. And then the next thing is that your server will ask for the user ID and passwords. Once the remote worker authenticated, they can use the resources. All right. So now back with the two kind of VPN that you can provide. First is the what's so called the legal or the official kind of that things. For the legal one, you have to apply. We have to buy the certificate from an authorized CA. There is a CA, yeah? Certificate authorizer. Some company, they sell, their services is to sell the CA certificate. One of them that I can tell you is VeriSign. So you go to VeriSign website, you apply for a certificate with your email, and then they will give you some informations for you to follow up with the payment. After you pay it, then they will give you the certificate in form of a software. There is like soft certificate, digital certificate. So then that digital certificate, you have to inject it in your server. And any remote worker that wants to connect to your server that is already applied with VeriSign certificate, they also have to have the client certificate. Yeah, you can generate the certificate for them because you already have the private certificate. That's called private certificate. Then you can generate a public certificate for the remote worker to connect to your server. See? But the thing is that this certificate is accepted globally because it comes from a CA, yeah, a certificate authorizer, such as VeriSign. Okay, that is the first method. The second method is if you only want to have a secure connections as a lab, that means you don't have you do not need that your certificate is work for globally. You only want to make it valid for your remote worker and you. So you can use what's called Open SSH. It's a free tool. You can use Open SSH. You are the CA, yeah, but this one is like quote unquote the fake CA. Yeah. But it works, yeah. It really works. So you install the Open SSH in your server. Once you install it, you become the CA. Then you can generate the public certificate also to your remote worker to connect to your servers. Okay. And that's not paid because it's open source. And anyway, it's only for testing. And what is the impact? If you already install a server with OpenSSH, and then you want to publish your application so that people from internet can access it, it will not work because your certificate is invalid. Yeah. So you need to apply a valid one like from VeriSign kind of authorities. All right. All right. Next questions? Yes.
So, I have one a curious question.
Yeah.
So, I believe you have experience real world in the client side, okay, with the I mean AWS AWS services. Did you ever find any attack from hacker or if yes, what it looks like the hacker attack? Because
Okay.
I mean we have to what is that? So we build trust in our clients, so we can still still have the trust from the clients. So what
Yeah.
it looks like is
All
that's
right.
much.
All right. Well, to share with you a little bit about the hacker. The good thing when you put your system in the cloud, and if you know the way hacker work, there are some steps before a hacker can go into your system and do whatever they want. First of all, you cannot just go in straight to your VPC because you still remember the outer box of VPC is a region, and region is a part of AWS cloud. Yeah. That means if a hacker needs to hack into our VPC, they have to go all the way to AWS cloud first and go to specific region which our system resides. Okay, The thing is, AWS Cloud itself already protect themselves from a lot of famous attacks in the world or common attack in the world. Some of them is like DDoS. Yeah, they already have their protections against DDoS and other malware and everything. Okay, so it's very rare for a client to feel the attack like what you ask. We ourselves, we never been experienced of the attack, but the AWS thousands of times get attacked from the hacker. Okay. One of them, if you ever remember, there are like 2,000 companies in the world down because AWS got attacked in the DNS system, the Route 53. It down for 3 days, if I'm not wrong. Then after that, it go back to life. That's because one of them is because of the DDoS. Okay. If you ever learn about, if you have computer networks in your syllabus when you're still in the college, we discuss about network security. And we discuss about hacker over there and their behavior. So first of all, hacker will try to snap into your network. They will attach to your network. Okay? That's easy. No one can prevent that. Nothing. Because, well, a network is designed for access. So anybody can access it. Okay. And then they just go there and eavesdropping means like listen to the network. What is passed through the data? They sniff it. Okay. There is what's called sniffing. Okay. First, eavesdropping or listening to the network traffic to get any data that is useful for the hacker to look some weakness so that they can go in. Okay. From those data, they analyze it. Once they got some clue, and then they will try to attack it. The most common one is brute force attack or dictionary attack. So they have list of password that they can automate it to try millions of trials to log in into your system. They have a massive list of password in their dictionary. So that's why it's called dictionary attack. Okay. Along with dictionary attack, they also use the brute force attack. So that means they challenge the system with the credentials from the dictionary. Okay. Well, simply saying, if they manage to get in your system, then that's it. They will do anything they want to do. They can delete your data. They can modify your data. They can fake the data as if it comes from the authorized person. A lot of things that they can do. And they also can like create a tunnel for them as another alternative of door that they can do, like log in and log out from that door, yeah, from that hole of security. Okay. So again, if you ask my experience, most AWS client around the world, they never experience such an attack because the first one to get attacked is the AWS cloud. Remember the shared responsibility model? AWS cloud is AWS responsibility. So we never experienced that. Okay. But from the internal, there is also a latent threat. Yeah, latent threat. What it is? It could be virus. So we can spread virus because Virus is just a file that will run in your system. You can accidentally copy that file and it will live within your system. Yeah. And then do according to the virus is designed for. That is first. Second, you can accidentally open the access for the world. Well, one of the very foolish things to do is to later on when we discuss about security group, yeah, routing table, you can allow internet access, internet users. We say internet users is 0.0.0.0/0. That means all over the world can go into your VPC. That's possible. That's a foolish thing. Even though AWS will warn you when you put in the routing table 0.0.0/0 to whatever your network given by the AWS is, and then there will be a warning. You are letting the world to access your resources. Are you okay with that? If you say okay, then everyone can go in. Yeah. So that means a misconfigurations or configuration mistake. That is latent threat. So first, virus. Second, misconfigurations or configurations mistake. Okay. Well, if you talk about security, it doesn't have to be like hacker go into your system, but network security or security touches the aspect of availability, well, authenticity, yeah, and performance. So when we talk about hacker, it's about authenticity and authorization. Okay, they try to get access. That's to authenticate themselves and to authorize themselves as if they are the user of the system. But the third aspect that people tend to forget is the performance. You know what is DDoS do? They will flood the network with data so that the traffic will be bloated, will be stuffed, and no one can pass through. It's just like the toll road gets stuck, get jammed. Even a motorcycle, even a people, like cannot walk among the cars. So it's very full. The network is tough, and it needs some times to let the traffic become available again. But then the DDoS attacker will not let the network to be available. That means if like the flooding happened in Jakarta, if there is no place for the water to go out, then the water will be there forever. We got flooded forever, right? That means you cannot pass through from your house. You want to go to the office, you will be blocked by water. That's the same like the DDoS attack. They flood the network bandwidth with some data. When it's full, no one can pass through. It's just like water blocking people. That means any service that you provide with your system, let's say the Tokopedia, if Tokopedia got DDoS attack and the network to access www.tokopedia.com is blocked because of the water is too much, then there is no way you can use Tokopedia.com, or AKA Tokopedia is down. You can tell like that because you cannot access it. But actually, the server is okay. The server is fine. The network is jammed because of the DDoS attack. Okay. Most of the time, the easiest one, DDoS attack will use a method called SYN flood. Yeah, SYN flood. SYN flood. If you ever learn about computer network, SYN flood comes from the TCP three-ways handshake. And because the TCP protocol has some mechanism before it's established the connections between the client and the TCP server, what is called as handshake. So it's three-way handshake. Okay. When a client wants to connect to a web server, let's say the Tokopedia, you are going to access Tokopedia from your laptop. Actually, your web browser will send a request to connect to Tokopedia web server. Your browser will send SYN plus X. And then the web server of Tokopedia will reply, will respond to the request. It will send acknowledge plus SYN also. Please accept me also. And then your web browser will accept the SYN request from web server, from Tokopedia. And then your web browser will send the acknowledge, to the web server. So it's like, first of all, first thing, when your web browser wants to access tokopedia.com, simple say, your web browser will say, please accept me. Please accept me, and this is my SYN, like synchronization, like my ID. This is my ID, please accept me. And then the Tokopedia web server will say, okay, acknowledge, please accept my ID also. So it will send ACK plus SYN back to your web browser. And then because web browser ID has been accepted by Tokopedia web server, and Tokopedia ID has been accepted by your web browser, the rest is for your web browser to acknowledge the request from your web server. So it's a ACK, acknowledge. So by those three ways, web browser access to accept, web browser access to accept also, and then your web browser say acknowledge 3 times, right? After that, you get established. The status of the TCP connection is established. Once it's established, it reach established, then you can get the HTML pages. So that's why it will appear in your web browser. So before a web page was sent from web server to browser client, there is a three-way handshake. And that SYN handshake, it's 3 times. Go back and forth from web server, from your web browser to web server to web browser. That's quite a traffic. If it's generated by like thousands of fake clients requesting for connectivity. Can you imagine that, right? Because hacker create a program as if this instance is a client requesting TCP connections to your web server. And your web server do not know who is requesting. Once it's got request, then it will respond with ACK plus SYN, accept me also. So this hacker create, please accept me, and then web browser will, foolishly say, okay, I accepted, accept me also. Please accept me, another one say, and then the web server will reply, okay, accepted, please accept me also. It's always like that. And you can imagine if like thousands of fake users in parallel requesting to connect to the web server, then the network traffic will be jammed. It will be flooded with SYN data. Even though it's only a couple of bytes, but if it's like thousands and happens the whole day, then no one can access Tokopedia.com because the network bandwidth is jammed, is full, flooded with all those information. Okay, so that is also the latent threat that might happen if you are accidentally download a virus, and that virus was created by a hacker to flood your network bandwidth. Then your service will be down. That's the same like the attack. Even though the hacker cannot get any data out of it, but it can make your service down. That's enough. For the security, the impact can be the service down. The impact can be you got robbed. The data is robbed out of you. The hacker can get the data out of your system, modify it, faking as a user that responding to any client asking for anything. So regarding the security, you only need to understand first the shared responsibility model. So that's why almost all AWS client never experience the attack from the hacker because it was hacked by AWS first. But it doesn't mean you are safe and sound inside the AWS cloud because there is latent threat. The latent threat could be virus and could be configurations mistake. Okay, so it's quite a long explanation, I think. Kevin, what do you think?
Yeah, sir. It's quite good insight for the latent threat. It's very new me, and I think for others too. And maybe I remember when AWS went down. At that time, I couldn't use Canva because Canva used put resources on AWS. Yes. Thank you, sir, for your answering.
Okay, yeah, a lot of people experienced that. That was a very bad 3 days, very frustrating one. You cannot, access some services. Anyway, any other questions? Yes.
Sir,
Yes.
speaking of the DDoS attack that you mentioned before,
DDoS. Okay.
can we prevent this DDoS attack? Like DDoS attack is like flooding our web server with a bunch of data at the same time from different IP, right?
Yeah.
So can we configure to block certain IP and allow certain IP to access our web server?
Yeah.
So that's my question.
Yeah. Of course you can. Okay. Well, this is a little bit out of topic. Yeah, but okay. It's okay. Just to make your understanding become more complete regarding the security surrounding the client VPN site-to-site kind of that things, why we need that, yeah? So I relate it to that. So if you say we can block the IP address, exactly, we can do that, yeah? So that's one of the preventions to do it. The thing is, if you say the hacker can create different IP address within a very short period of time. Like if you block one, it will grow another one. Then you have to block it again. Well, the thing is that, will you stand in front of your firewall and then you configure each and every different IP address appear? It's not make sense also, right? The thing is that if the hacker can generate 1,000 clients within a second, how many times do you have to reconfigure your firewall to block those IP address? It's impossible, almost impossible, right? And the second thing is that I told you before a hacker can get into a system, they will never go attack. At first time, they are not doing the attack. At first, they will go into the learning mode. What is the learning mode? Like I told you, they will try to sneak into your, attach to your network and listen to the traffic. They will learn the data pass through first. Second, they collect the data and then they will analyze it. That is called sniffing. They will sniff your data and analyze it. Once they analyze their analysis enough, then they will launch the attack because they already know what is your IP network address, what is your server available. Oh, there is DNS, there is web server, there is file servers, there are FTP servers, all those things. They learn it from your traffic. How do they know that? Well, again, if we learn computer network, if you ever learn computer network in your major, we learn what's so called the OSI layer. Yeah, in the perspective of network OSI layer, there are 5 layers, if you still remember that, from the physical layer, data link, transport, network, up to application layer. So in the network layer, we know that every applications will be represented by one port. So by port scanning, the hacker knows what is available. Like if they scan port 53, if it's available, that means you have a DNS. If they scan 2022, that means you have SSH server, open SSH. If they scan again, you have 21, you have email server, and so on. So they know, they learn from the traffic what kind of services you have in your system. And then all those services always have a hole. So that's why like Microsoft, Google, Ubuntu, Linux, yeah, mostly Linux, they have patches for their system, for the operating system. So there are some holes that there will be security patches, yeah, to mend the hole, yeah, to fix the hole, the security hole. Okay. So when they have learned all the data from your network traffic, they analyze it, they learn it, and then they think, finally, you get this TCP, let's say Flask. If you know Flask as a Python micro web framework, if you play with Python, and then you want to expose your Python code into web applications, you might need a Flask server. So when they sniff, there is port 5,000s or 55,000s, or the range is up to 8,000s, right? So if they scan that, you might have a Flask server. And then if you don't apply the SSL Flask, the secured Flask, that means it's the same like HTTP port 80, because Flask also using TCP. And if there is no SSL, it's just like a naked web service, like port 80, not port 8443 or SSL. So it's not HTTPS, it's HTTP. So if they learn that, wow, there is a lot that they can do with naked TCP services. A lot, yeah. And then if they have learned that, you got this port open and not secure, then they will start the launch. They will send you some files, and then you will accidentally or unrealizing it, you accept it, and then it will run within your system. Yeah. What is the possibility? A lot. If they can send the Trojan into your castle, if you watch Hercules, yeah, Hercules sent the Trojan horse into the palace. So that's where the Trojan horse virus comes from. And then at night, the Trojan horse will leak out the people to attack the palace. So that's the same. They send you a file that will generate, that will work, that will activate it when all the system is sleeping. So perhaps midnight, there is no activity in the server anymore, and then it works. You might not notice that. And then it will work whatever it is. It can go to your database, because usually when we are already in the local network, there is no HTTPS connections among servers within the same local network. So when this hacker can send a file and then this file resides in the local network, it will, feel very free because it can move here and there without any secure connection. So it can freely access your database, your SQLite, your MySQL, your any database, or they can go to your web server, modify it, change the logo of your company, and even posted some, funny clown picture in front of your homepage, whatever they can do once they get in. Okay, so well, it's not merely blocking network IP address only, because it's almost impossible to do that. Because when you say blocking it, you are referring to an administrator sitting in front of the laptop, configuring your firewall and keep restarting your firewall to apply the new changes, kind of things. So it's almost impossible. The thing is that you have to install some virus monitoring, hacker monitoring things. Yeah, preventions, kind of that. A lot of preventions software that you can apply, or procedures that you can apply. So security is not merely about software to software, but also software to policy. You can apply some policy to defense your system. Right? If you ask me about that, I can talk like a whole day. Maybe we have to continue with our material. Yeah. We will have the special sections about the security. Maybe you can discuss more about security if you have real interest in that security things. I'm teaching computer network also last semester, and this semester also I'm still teaching computer networks. So it's still very fresh in my mind regarding the network security, hacker attack, and the preventions, all those things. So you can always ask me about that if you have interest in the security. All right, I think that's Mr. Toyib.
Okay, thank you, sir.
All right. All right, I think it's 10 o'clock. We can continue with the last one. It's about the private link. Okay. So the scenario is like this. Another companies sometimes need the flexibility to privately connect to resources in other cloud providers as though they were in their own VPC. So this is different case. So cloud to cloud. Okay. They need a way to communicate with these resources and do not want to hassle of setting up gateways or site-to-site VPNs. They do not want kind of that things. And then AWS have another offer. They can use private link. Yeah. And what is private link? Private link is a highly available, scalable technology that you can use to privately connect your VPC to services or resources as if they were in their own VPC. Okay. So you have to imagine we have one VPC of our own, okay? And then we have some resources or services in another cloud providers, let's say Azure or GCP, Google Cloud providers. The thing is, we do not want to log out from our VPC and log in to Azure or to GCP and then access the resources, and then somehow we download the files and everything, and then we upload it back to our VPC. That's tedious. We want to connect. Why we want to connect? So that we can treat it as if they're our own VPC. Well, if it's everything is within our VPC, it's very easy, right? Because it's already in our quote unquote in our home. Okay, in that case, you're going to use private link. Yeah, private link. Well, can we use side to side or any gateways? Of course. But the scenario here is the customer don't want to hassle setting up gateways or side to side VPN. So another alternative is private link. Yeah, and private link highly available. If you see site-to-site VPN, highly available, okay? And then if you see client VPN, that is it. There is no high availability because it's, yeah. Okay, because client VPN, it's not mentioned about highly available because it's one-to-one connections, yeah? So remote worker have VPN client or certificate connect to AWS, and then once done, disconnected. So there is no urgency to have the highly available things. Yeah. But the site to site, because it's data center to AWS cloud, we need to have a highly available. Why? Because the connection is like multiple like this, you can see. If the VPG is not highly available, then all these branches, all these data center manufacturing site cannot connect to the VPC. Well, it's not about 1, 2, 3 sites, but the users within the site, like how many people in the branch office, in the data center, and the manufacturing site that cannot access the resources in the VPC. Well, you can say like the operational is down. Yeah, so it's very critical to have a highly available services in the VPG. Yeah, so that's why it's highly available. It is designed to be highly available. Well, who's responsible is this? AWS. So you don't need to worry about that. You just need to know, oh, okay, it's already high available, so I can use this one, right? And then private link also highly available. And more than that, it's scalable. What about the VPG? Is it scalable? No. There is only one connectivity. Yeah, but it's highly available. Highly available means if it cannot be done. Yeah, as simple as that. The service cannot be down, so that's enough for you. Yeah, even though it's one, but it is always available. It's highly available. You can always connect to here. Okay, but then private link is more sophisticated. It's scalable. Means like not only one, but it can be multiplied. Yeah, that's scalable. And then the thing is, if you use private link, of course, it's like direct connect. You don't have to have internet gateway. Remember that? We do not want IG. We don't go through IG. We don't go through FreePG, right? We don't go to NAT or anything, but it's just directly connect, yeah, using private link. So we can privately connect VPC to services and resources. Yeah. You do not need to use IG, Internet Gateway, NAT device, Network Address Translator device, or any public IP address. Direct connect connection, you don't have to have direct connect connections or AWS site-to-site VPN connections, just to allow communications between your AWS and the resources from your private subnets. Okay. Instead, you control the specific API endpoints, sites, services, and resources that are reachable from your VPC. Okay. So you can tell that actually private link is kind of like API services available for the customer. So if you want to connect to a resource, then you have to speak using the API endpoints. Yeah. So a little bit about this one, that means you have to connect using some kind of like programming. You can do that. Or you can do a configurations within your VPC so that once you configure it with certain API endpoints, that means that endpoints will be reflected into your VPC. So let's say the API endpoints is EC2. There are like 100 EC2 that you want to access from within your VPC. But the thing is that that EC2 is in Azure. Okay. And then you can expose the Azure endpoints and put it in your configurations, in your AWS VPC configurations. Sorry, in your AWS private link configurations. You type in the API endpoint, https microsoftazure.com/something/something like that. By that way, your private link already been connected to your Azure. And you see it as if the resources is within your backyard. It's within your VPC. Okay, so you just have to configure it away in the private link, and then you get all without, any site-to-site VPN, any direct connect, any IG, whatever, right? So it's very, very convenient to use private link. The benefits, private link helps you secure, it's still secure, the traffic, and you get connected with more simple management rules because you only configure it within your private link. That's it. And it's secure. Yeah, that's important. Secure and easy. Use case, usually it is used to connect your clients in your VPC to resources, other VPCs, and endpoints. It could be the same AWS, but different VPC. It could be different
Harus
cloud
bareng
provider.
agas itu.
And then the client wants to connect to that. Then you can use private link. Okay, so this is some side notes regarding the connectivity. Even though the preceding connections are highly available and scalable, traffic jams are possible because you are using the same connections as other clients, which is the internet. Remember, this is the same like site-to-site VPN. It's still using the internet connections, but VPN make a tunnel. But remember, to access this tunnel, you have to go all the way to the internet connections first, which is used by other clients, right? So that means the traffic in the internet traffic, internet highway can cause traffic also can cause performance slowdown in your VPN connectivity also, or traffic jams, yeah, because we are using the same connections as other clients. So that's why for some use cases, you might need a dedicated private connections with a lot of bandwidth, and it brings us to direct connect. Direct connect has different paths. We are not using the same internet connections like private link, like VPN. So there is a physical fiber cable connected from your data center right to AWS cloud. Well, through the direct connect provider like Lintasarta, like I told you. So we go to Lintasarta, there is a switch. Okay, AWS put in port 1, and then the client like Telkomsel put in a port 2, and then the Lintasarta engineer will create a route from port 1 to port 2 and back, port 2 to port 1, opening some available protocols, kind of that things. That's it. And then, you are directly connected through fiber, high-speed fiber optic. Okay. That means we are not going to internet, but it's through the fiber direct connect. So that's why it's called direct connect. It's a service that makes it possible for you to establish a dedicated private connection between your network and VPC in the AWS cloud. The benefits is it reduces network costs and increase amount of bandwidth. Well, when it comes to cost, we need to consider a lot of things. Yeah, but it's not apple to apple because direct connect connections, it's exclusive, it's expensive. Maybe you can say it's super expensive, right? So reducing network costs, but in another side, the direct connect itself is very, very expensive. Okay, so in terms of cost, you need to see from a lot of angle. The case using direct connect is a corporate data center routes network traffic to an AWS direct connect location. That traffic is then routed to a VPC through a VPG. Yeah, so you can see here, like I told you, simply port to port, but then at the end of the AWS VPC, it's still VPG. Yeah, like this. This one. It's still VPG, but you can imagine the line here is a fiber cable instead of internet connections. So this picture is still using internet connections. So that's why it can experience traffic jam. But direct connect from this point to this point is fiber channel. Okay. So it's still VPG. Yeah. That means we have to have a VPN client path. Exactly. So VPN client here, VPG, but instead of internet connections, this is direct connect cable, fiber cable. But the connectivity itself is secure by VPN. This is VPG, so this is supposed to be VPN. Yeah. If this is VPG, this is not VPN, can it do? No. Yeah. VPG only accept the authorized client. In this case, a VPN client. Yeah. If it's not VPN, then you cannot access the VPG. That means you cannot go in the resources. Okay. I hope you can challenge yourself like back and forth. Yeah. So you can really grab the understanding of this connectivity. Okay, so again, a corporate data center routes network traffic to an AWS direct connect locations or direct connect provider. In this case is Lintasarta. Then that traffic is then routed to a VPC to AWS cloud through a VPG. So from Lintasarta to AWS through a VPG, connect to a VPG. All network traffic between the corporate data center and VPC flows through these dedicated private connections and secure, because it's VPG. All right. So to learn more about direct connect, you can see first latency sensitive applications. If you have that, then you can use direct connect. Direct connect bypass the internet and provides a consistent low-lag network experience. This makes it ideal for applications like video streaming and other real-time applications like voice, yeah, that require high performance. Okay. So if your company or the client is a video streaming provider like video, Netflix, kind of that, then they might want a latency proof, yeah, latency proof. In this case, they can use direct connect. Means like they have their streaming server within a VPC, AWS Cloud VPC, and then for the people to access the video, the content, then the client needs a VPN client, and then they can directly connect to the Netflix or to the video through the direct connect. Okay. And then second is large-scale data migrations or transfer. If you ever happen to, migrate large-scale data or transfer, you can have a contract for a certain period of time for this direct connect. So it can be not forever. So the contract per se, you are moving your data center from one place to another place, and then you want to transfer the data through the network. But if you are using VPN to VPN, it's still very slow because your data might be like petabytes. It will take days, and the consequence, if it's like disconnected during the transfer, then you have to retransfer everything. It will be very, very frustrating things to do. So you might want to have a direct connect for a certain period of time. Then you can go to Litasarta and sign a form, say that I'm going to do a migrations for like as long as like 6 months. But if I finish it earlier, I would like to terminate the rent. Maybe there is some terminations fee and kind of that thing. So you can talk that out with the direct connect provider. Okay. After you have that, then you can do a large scale data migrations transfer, right? And then the third one is if you have a requirement for hybrid cloud architectures. So you might want a direct connect, like what we have with Telkomsel. So Telkomsel have the hybrid cloud architecture. They have some data in their on-premise, and they have some applications running on cloud. So their applications cloud that have the requirements to access their data back in the on-prem. For a high performance one, they do not want to have latency for that. So they have the direct connect in place. Yeah, since the applications like live forever, so they have the direct connect like almost forever. I mean, like they pay every month. So it's like renting infrastructure, yeah, like hosting your server. If you don't pay, then it's it. Then it's terminated, right? So the same like Telkomsel. As long as they pay the direct connect fee every month, they're fine with the direct connect. But then, of course, there is some prerequisite, like 3 months prior to contract end, then you have to extend. Otherwise, you will be terminated, kind of that things. Okay. So there is another additional gateway services. We can use this type of gateways if we want to connect to the AWS resources. It depends on the needs. We might want to learn more about this. Okay, we see one of them is the AWS Transit Gateway. So the ATG or AWS Transit Gateway is used to connect the VPC and on-premise networks through a central hub. Yeah, not VPG, not IG, not private link, but it's a central hub. So we can see that if our cloud infrastructure expands globally, inter-region peering connects transit gateways together using AWS Global Infrastructure. Okay. So let's see about this one. I'll just click here. Let me share the screen with you. All right. So the case is when your network grows here, when it grows, the complexity of managing incremental connections can slow you down. Like we have more VPC, and then we also have on-prem, and then we want all those things connect together. So you can use Transit Gateway. All the VPC will connect to Transit Gateway, including the on-prem network. It will connect to the Transit Gateway services. We'll see.
AWS Transit Gateway helps you simplify and scale by connecting your Amazon virtual private clouds and on-prem.
Still not working? Okay, later you watch by yourself here.
Premises
Well, at this
networks
time,
and grew
a lot of
gateway
people
solve. It even connects
using the
across
internet in Sudirman 7.8 building, so we got to slow down. Anyway, yeah, so the concept is you have more VPCs, more than one VPCs, you have on-prem, and then everything wants to connect together. So you might want a central hub to simplify the connectivity. Yeah, so any VPC, you have like, let's say you have 3 VPCs and 2 on-prem, 1 on branches, 1 on data center, 1 on the manufacturers, what we see before. And you also have more than 1 VPC. And then you want to connect this all together. If you connect it traditionally, it will slow down the network because the topology will be a mesh. Okay, mesh topology. So we can centralize everything to simplify the topology, and then also to be able to centrally focus on one hub, one central, instead of a lot of points. So ATG, AWS Transit Gateway, will act as the central hub. So all VPC can connect to the Transit Gateway, and then also the on-prem can connect to the Transit Gateway. And then what happens next is any resources from VPC can be accessible from any on-prem and vice versa. Okay. And then another gateway services that you can use to connect to AWS resources is called NAT Gateway. This is like very common, yeah? Because NAT Gateway is used so that the instance, in this case is EC2, in a private subnet can connect to services outside your VPC. But external services cannot initiate a connections with those instances. Okay. Let's see if you can see this. So the idea of NAT Gateway, we have public subnet, we have private subnet, and then you create some EC2 instances in your private subnet, and you want that the EC2 in your private subnet connect to some services out your VPC, can connect to another VPC, but commonly we want the EC2 within the private subnet can connect to the internet, because you might want to install Ubuntu Linux per se. Then you have to have an internet connections so that you can install your EC2 within the private subnet by downloading some files from the Ubuntu Linux repositories, kind of like that. But the thing is that those resources out of our VPC, in this case is internet, anybody from the internet cannot get in. That is what is good. Yeah, but also a problem. Sometimes we want to manage this private subnet, and we cannot go like SSH into this NAT, through this NAT gateway, and access our EC2. And then people will create what's called a jump host, yeah? Jump host, or a bastion host. So it's like you create an EC2 in your public subnet, and then this EC2 will be dedicatedly connect to the EC2 in the private subnet. So if you want to access your private subnet, you have to jump, yeah, to leap, to get in to your jump host first, to this EC2 resides in the public, and all the way you can use this public subnet EC2, public EC2 to connect to the private. So that's why it's called jump host. You jump to the host by means of this EC2. Yeah, hope you understand that. Well, oh, there is no pictures or anything. Well, you read it by yourself. It's quite a lot. But the idea is like that, yeah? So you have private subnet, you have EC2 instances there. You want these instances to be able to access some internet resources or other VPC. Yeah, then you might want to enable the NAT gateway service. And this NAT gateway, you have to remind if in the certification exam, there is like the questions, NAT gateway only have one way out. There is no another way in. Yeah, it can only be out, not in. Means the instances within the private subnet can access the internet resources or other VPC resources through the NAT gateway, but not the other way around. Users from internet cannot get in to your private subnet, or resources in another VPC cannot get in to the private subnet through that gateway, because it's only one way out. Remember that, yeah? It's different to internet gateway. Internet gateway is two-way. It can go out and in. Yeah, you can let people out of the internet to get access in the VPC resources. But NAT gateway, there is no configurations to let people from internet or other VPC to have access within your private subnet. Okay. The next gateway services that you can use to connect to your AWS resources is using API gateway. The API defines how different software systems can interact and communicate with each other. And then AWS provide the API gateway service. So we can create an API endpoint, publish it, maintain it, monitor it, and securing it at any scale. So it's scalable. Yeah. And then how are we going to access the resources through this API gateway? If it's API, I think if you have time, you want to try out how to do API programming. Maybe you have a big picture of what is API gateway. So basically, it's borrowing from the transit gateway. It's a central hub for all the APIs you create for other people's mean from internet or from other VPC to access your resources. So to access the resources, you have to go through the API way, yeah, which is from programming. So you can program an API client to consume the API services created in the API gateway, in the AWS API gateway. Okay. Or if you do not want to create a program, a full program like using Python or other, you can also use the API client like Postman. If you ever heard, you can use Postman just to try how to connect to AWS and access the resources. You can use Postman, especially if you only want to get access for one time. Yeah, so it's not permanent. No need to, create a program for that. All right. So we have a lot of jargon also here. There is another flashcard for you to look briefly. What is Direct Connect? Private dedicated AWS connections to your data center or office. There is a physical work, yeah, physical work to pull the cable, the fiber channel. And then VPN, AWS client VPN connects remote workforce. In this case, is the employee who wants to work from home to AWS or on-premise using or through a secured connections by means of VPN. So that's client VPN. And the third one is site-to-site VPN. Site-to-site VPN. Site-to-site VPN, encrypted network connections to your Amazon VPC. So basically, it's almost looks like client VPN. It's just that this is not from individual to AWS cloud, but from a data center. So from a network to network. In this case, is data center network to AWS cloud network, site to site. What is the difference? Client VPN, individually you get connected to AWS cloud. But site to site, once your data center is connected to the AWS cloud, anybody log into the data center can go through the site to site all the way to get the resources. Yeah, so it's like group. You can imagine it like as a group. Instead of one by one configurations, you configure it as a group. Then the group member can access the services. Okay. Then last one is private link. Private link connects your VPC privately to services and resources as though they were in your VPC. But this is not via internet gateway, not client VPN, not site to site, not even direct connect, but this is VPN to VPN, but this is among VPC to VPC. It's not individual or data center to one VPC, but this is between or among VPCs, so that resources from another VPC can privately connect to our VPC, and then after that, we can, or the VPC resources can access the other resources in other VPC as if they are in their backyard. Okay, let's test our skill, just a refreshment. So a company is conducting a large-scale migrations of their on-premises data center with their data warehouse and their data backup. They need a solutions that will meet the large amount of bandwidth requirements during migrations. This is a keyword, large amounts of bandwidth, yeah, to transfer data, to migrations. The solutions will also be used for their ongoing data transfer, and they want an ongoing one. That means permanent after they move, because they will retain part of their on-premise data center for a hybrid cloud solutions. Hybrid, large scale, and then a data transfer. So what could it be? Client VPN, site-to-site VPN, private link, still using the VPN, but if you need a large one, transfer, And to maintain hybrid, then I think it's direct connect. Okay. Okay, there's another one. The company is choosing the type of gateway for their network. They need to connect their corporate data center with their private subnet in their VPC. Okay, then you see this, choosing a gateway to connect corporate data center on-prem to private subnet. Their gateway needs to allow only protected internet traffic. This is a keyword. Protected internet traffic means VPN to enter into the VPC. Yeah, so it could not be internet gateway, yeah, because it's supposed to be VPN. So at least it's VPG. It should also allow connections between the Amazon VPC and a private network only if it's coming from an approved network. Yeah. So you see, it allows connections between their own VPC and a private network only if it's coming from an approved network. So it's network to network. Yeah. This is the key. Network to network could be VPC to VPC, protected. So it's supposed to be VPN, kind of. At least it's supposed to be VPG, not IG. But we have another one also. It could be site to site. It could be private link. Yeah. But I don't see any any clue for the private link. Yeah. Private link, it's out of the. So which one would it be? Internet gateway, of course not. VPG could be. Transit gateway, let's put it in our pocket first, and API gateway. Okay, so it's not about API gateway. There is no things like API things, yeah. And then also transit gateway, that means there is on-prem, but I don't see, okay, there's on-prem to the private, and then VPC to VPC. So there is on-prem to VPC, and then VPC to VPC. So it's not only virtual private gateway, yeah? Because virtual private gateway, it's it could be like only a remote worker. But to be specific, if there is on-prem, there is VPC also. It could be these two, transit gateway and API gateway. But the difference between transit gateway and API gateway is that the API, they provide the API. There is no such thing as API here. And I would answer this as transit gateway. What do you think? Before I submit, let me see your answer. What is your answer?
I think it's VPG.
VPG, okay. Okay, number two. It could be VPG. Even direct connect is connected to a VPG also in the VPC, right? VPG is the general one. B, okay. Another one? Don't try it first, yeah? Later you try it first. All right, two. Okay. Okay, great. If everyone agree with 3G, let's see, yeah? If it's a 50G. Okay, it's a 50G. Well, if you see, actually, this is very like if you know more, people say you'll become like dumber. Yeah? It's actually indeed like that. Okay, in that case, you have to think like the ATG is something different to VPG. So the inter-region peering connects to transit gateways. So if you have another VPC, you have on-prem, and then you can connect to ATG without connecting to VPG. Yeah. So you have to find a unique characteristic that it's the only answer. If it's not, when you do the certification exam, it will be confusing. Yeah. Okay. So it's VPG. Then have to browse up to up. Okay. Maybe we'll watch this video. Hopefully it's not stalled. Our network is not that good. So it's 11 o'clock, almost 11 o'clock. So I leave this all behind, the network. And let me ask you about your assignments. Is there any problem? Do you all have the AWS console already?
Yes, sir.
All right. Okay.
Sir, I want to ask something.
Yes.
So I have read it and watched your reference video. So I just want that you mark us based on the use of the console, the CLI, and also the automation or Terraform, right?
Yep.
But from what I understand is that you can build it either from, I think you can build it from all of that three platform.
Yeah.
So
Yeah.
is it like, should we build it on each of that option, or like we mix it, like we check it on the console, build it from the Terraform, and like cross check it via CLI whether it is accessible or not?
Okay. I think this is the questions representing all. Yeah. So you can use only AWS console. Okay. But if you use also the automations, either you use CloudFormations or Terraform, it's up to you. And of course, if you use CloudFormations and Terraform, you might also want to use CLI, yeah, to execute the Terraform. CloudFormations, maybe you can use console to inject your CloudFormation script. But also you can use, I also send you the video of how to use YAML for the CloudFormations. Yeah, CloudFormations, you can use console to go through the CloudFormations one by one, but you can also create a YAML, which is almost the same like the Terraform. That's what I want to see, actually using YAML and Terraform, and then you execute it using CLI. Okay, that's very important in DevOps anyway. But if you use not only console, of course, your score will be higher. It's doable using AWS console, but you know, there will be additional score for anyone who use CLI and also either, yeah, don't have to use both, but either CloudFormations or Terraform. Okay. Why I want you to do the automations? Because when you already do the automations, you might leave the AWS console. It's tedious. You have to click here and there. So I challenge you to use the automations. Okay. Automations also using the script you can reuse. Like if you want to create EC2, you create the script. If someday you want to create another EC2 with different configurations, you just tweak into your script and then you execute it, done. So it's reusable. Different if you use console. You always have to go to console and create everything from scratch. Okay? So that is IAC, infrastructure as a code. Okay? Is that answering, Bagas?
Yes, it's clear, sir. Thank you.
All right. Any other questions?
And sir,
Yes.
for the presentation, at least 2 minutes or the maximal
Maximum 5 minutes.
or maximal 5 minutes. Okay.
Yeah.
I see
Anybody
that.
more than 5 minutes will be discounted.
Okay, okay. Okay, sir. Thank you.
All right. So that's including the demo, yeah? 5 minutes, presentations and demo.
Sir, I want to ask
Yes.
for the demo. Is it we start from rerunning the creating from scratch from the script, or the demo is only we test whether we can connect to the instance from the internet, or how, yeah?
Well, the demo, it depends on you.
Oh,
If you do more complete things, of course you get additional score, additional points. Yeah. Like you already created, it's done, but you're not tested, then how? How do we know that it works?
mhm.
So you have to think about that. Yeah.
Yeah.
So that's the variations. I leave that, like I do not really make the detail of what you're doing, but I leave some space for your creativity, for
Either
your
from,
sense. If
I think you can
this
build it.
is how you are going to face the customer might want something like a requirement that is not complete usually. But with your capabilities and capacity, you can think like, oh, okay, if I only give this, the customer will ask another questions again. So I will give it end to end, something like that. So I leave that part of creativity to you. And then that will make different score for everybody. Okay. That is one thing. The second thing is that, do I have to do it from scratch? Well, you only have 5 minutes. You want to do it from scratch, or you want to do something else? That's also your creativity. But you cannot unfinish your demo and presentations within 5 minutes. That will be discounted. Okay, so you measure first. When you do the preparation for Monday, you try it yourself and time it. See how long will it take for you. Yeah. And my tips, I already give it to the group. You have to note down every single step that you need to recreate what you have done. If you say I create the script, then you have to write down the step. One thing that if you use Microsoft PowerPoint, I cannot see the part that is the comments here. And down at the bottom of the Microsoft PowerPoint, there is a notes that you can put for yourself. It's like teleprompt for you. So you can put all those things there. Okay. If you have to put your words there, okay. I know, like, this is our first time, like, doing the presentations and demo in English. Maybe you might want to put all your speaking in your notes, in the PowerPoint notes. Then you read it. That's fine with me if you read that. But the way you read it, you see when I read some material here, okay, I don't really read word by word, right? So you have to read it as if you are speaking. You cannot read like a subnet is a section of a PC in which you can group resources based on security or operational needs. Subnets can be public or private. Public subnets contain resources that Got it? So you have to say a subnet is a section of a VPC in which you can group resources based on security or operational needs. Subnets can be public or private. That's fine with me. Okay. So that's also will help the other audiences to understand you better. Instead of like you are reading it. If you're reading it, you don't have to read it. You send it to me. Then what's the presentations for? You look into the sections that Mas Adi already give you, how I score you. So there is intonations, pace, all those things fit into that. Okay, that's how I, score your presentation skill. Yeah. The voice, the tone cannot be flat. That's different. Have to be dynamic kind of that. All right. So you try all those things, put it within the time frame, 5 minutes. Yeah. Somebody that is more than 5 minutes, I consider it not prepared well because you have not timed it, you have not practiced it, so you do not know that your presentations and demo will exceed 5 minutes, of course, right? So you will not get a good score. Okay? Is that clear so far? I think this also for the other, yeah?
Yes, Pak.
Yeah.
Once more. So for the this one for the presentation, right? And for the video recording, it is it we record step by step from the very beginning, yeah?
Yes. When you
Oh,
try already, oh, okay, I'm done. Okay, then you repeat again for recording.
yeah.
But before you record, you write down step by step. And then while you are testing your steps, you can record it. Okay, so you're not working twice. After you record it, you see if you need to edit it, you edit it. You cannot exceed 5 minutes. Okay, but the demo itself may be less than 5 minutes, right? Maybe only 2 minutes. Okay, so if you're smart enough, I mean, while you are doing the demo, you can also speak what is in your presentations. Because the presentation is all about your demos, right? So no need to use demo, okay, and then presentations, blend it together. Okay, I think it's more, 5 minutes is too long already. Usually it's 3 minutes. I have that before with my students, and at the time we only, in average, 2 minutes, maximum is 2.8, 2.75 minutes. Not, it's less than 3 minutes. But if you really prepare it well, don't speak any sentences that is not required. Okay, be efficient and effective because your time is limited. All right. Okay. Other questions? Yes.
Sir, I would like to ask the same thing about the presentation. Regarding the presentation, it will be sort by absent, or we can request in advance who would like to present, yes, sir?
Yeah, you can request for advance.
Okay, thank you, sir.
Yeah. And remember, you only 15 people. So if one people maximum is 5 minutes, you have 75 minutes. Yeah. More than that, if the time's up, then the person who has not get the sequence to do the presentations will be left behind, and there is no point for that. So I will not wait for you you cannot wait for me to ask you to do the presentation. If it's possible, you can discuss who will go first, who will go next, and so on. Okay, so everything will flow smoothly. Okay, Teku, is that?
Understanding, sir. Thank you.
All right. Any other questions? Yes.
Sorry, sir. I just want to confirmation again. We can do all presentation through the all video recording, right? From the we explain about PVC, subnet, and demo. Is it
Yes.
okay?
Yes.
Okay,
Yes.
okay.
But since I mean, like, since the video will takes up a huge file, I'm afraid if you include your presentations in there also, there will be like a very huge videos. It's better for you to only record your demo.
Oh, I see. Okay, okay.
Yeah, and then don't forget to compress it.
Okay, thank you, sir.
Okay. Other questions? All right. If there is no more, I'll leave you to do your self-learning. You can continue with your assignments for Mondays, or you can try another videos regarding the networking. I think this is like the repetitions of what we have watched yesterday. Yeah? This is that I just want to, why I want to repeat, because I want to emphasize so that you really understand about the networking and connectivity within AWS, because this is one of the core topics in AWS. Okay. All right. Thank you very much. See you.